Hi, this is Arlissa with 8-Minute Maths, and this video is about solving the systems of equations. As you can see, there are three types of systems. One is independent, which means it has one solution. Inconsistent systems have no solutions, and dependent systems have infinitely many solutions. So as an example, an independent system would look like this. You'd have two graphs. Let's say one here and one here. Where they cross, this is just one solution for an independent system. If you had an inconsistent system, would be where you have two lines basically that run parallel, means they are never going to cross each other. And then you have dependent systems, which means they are, for all intents and purposes, the same line. These two graphs are the same line. They are exactly the same, so it's a dependent system of equations. So there's several ways that we can solve systems of equations. One of the ways that we can solve systems of equations is by graphing. We can solve by graphing. When you're solving by graphing, you can either graph it based on T-charts, taking a T-chart, finding 2 or 3 points, graphing those, or you can put them into the y equals format. So we're going to do one example of each, so that way you can see that it can be solved two different ways. Example 1, we have 2x minus 5y equals negative 25, and negative 4x plus 5y equals 35. Let's use T-charts. Okay, so we're basically going to take this first equation. We'll pick an x value. We've got 2x minus 5y equals negative 25. And when this is all over, we should have some y value on the other end. Let's start off. I like to start with 0. So we substitute 0 in place of our x. So we've got 2 times 0 minus 5y equals negative 25. Negative 5y equals negative 25, and y equals 5 because we divided both sides by negative 5. So our value here is 5. Our point would be 0, 5. So let's pick another point. Let's pick, easy enough to choose. Let's pick 2. So 2 times 2 minus 5y equals negative 25. So we have 4 minus 5y equals negative 25. We subtract 4 from both sides in order to solve this equation. Negative 5y equals negative 29. Divide both sides by negative 5. We have y equals positive, what's this, 5.5 4/5. So 5.8. 2 and 5.8. So our next graphing point is 2 and 5.8. You can continue to get some additional points, but if you believe you're good enough to do with 2, then 2 points is really plenty. Then you need a T-chart for the other graph. So let's go with x and negative 4x plus 5y equals 35. Then we have a y over here. Again, let's pick 0. Negative 4 times 0 plus 5y is 35. 5y equals 35, so y equals 7. So our value here, our point here, 0, 7, is the first point to go with this graph. Okay, then we can pick, let's pick 5. Let's go with -5. Okay, -4, and I just randomly picked the number, so it doesn't matter what you choose. We have 20 plus 5y equals 35. Subtract 20 from both sides. You have 5y equals 15, so y equals 3. So this point here is -5 and 3. Now that we have 2 points for each graph, I'm going to take this first one and call it the green graph. And for the next one, the other one, I'm going to make it the purple graph. I'm hoping you can see the difference in those colors. But let's look at these two. Looking at our points. Let's see what we have. There we go. We have, for the green graph, we have 0, 5 that we found, and 2, 5.8. This was for the 2x minus 5y equals -25. And for the other, which is -4x plus 5y equals 35, we found 0, 7 and -5, 3. Now, just so you know, it is always a good idea to find 3 points instead of just 2, because if you made some kind of mathematical error, having 3 points will make sure that you don't make some mistake with your line. But let's go ahead. 0, 5. We're counting each of these by 1. So 0, 5, 2, 4, 5 is here. And 2, 5.8, 2 and 5.8 is up here. Okay. If we want to draw ourselves a line, we can. Draw us a line. This was the 2x minus 5y equals -25. Then we have our other line. We've got 2 points there that we can graph. We've got 0, 7. 0 and 7 is up here. And we've got -5, 3, -2, 4, 5, and 3. Oh, looks like we might have come across what crosses the line. Let's draw us a line between these 2 points. This graph is the -4x plus 5y equals 35 graph. And we can see here where there is a meeting place on these 2 graphs. We have at the point -5, 3. This is the place here where the 2 graphs cross each other. So that then will become the solution. Our solution is the place where the 2 graphs cross, and it is -5, 3. The way you can check to make sure that you have done it correctly is to substitute -5, 3 back into each of these equations to make sure that what you've done is correct. So let's go. -4x plus 5y equals 35. Substitute -5 and 3. We've got -4 times -5 plus 5 times 3. Does that equal 35? We'll see. 20 plus 15 equals 35. I'm thinking, yes, it does. 35 does equal 35. So this one is true on this side. Let's look at the other side. 2x minus 5y equals -25. Again, let's substitute -5 and the 3. Does that equal 25? Well, -10. Oh, does it equal -25? Sorry. Minus 15 equal -25. Well, -25 does equal -25. So this one is also true. So those two, this solution does satisfy both of these equations. So that does make it be a solution to that system of equations. 2x minus 5y equals -25 and -4x plus 5y equals 35. Okay, that's using the T-chart method. You can take the T-chart, find some points, put them in, and then solve for those, find your graph point, and go from there. Then you could also do another example. You can solve a system of equations by the y equals method or the slope-intercept method. Okay, we have two equations. This is our system of equations, and this time we're going to solve by slope-intercept form. Okay, we're going to get them into slope-intercept form. Let's start with the first one. 3x plus y equals -3. Well, the slope-intercept form is y equals mx plus b. Makes it kind of easy to graph it if we're in this form. So in order to get here, we're going to subtract 3x from both sides. These cancel out. We're left with y equals -3x minus 3. This is in the proper format, the y equals format. And then for the second one, we've got 2x plus 3y equals 5. Again, we want to get it into the y equals format, and we do that by subtracting 2x from both sides. Notice how I did not put this 2x and the 5 right under each other, because they are not like terms. So you can't just add them or subtract them from each other. Now we have to divide everything by 3 in order to reduce this coefficient. To simplify this coefficient, we have y equals -2/3 x plus 5 over 3. So now we have here equation number 1, and here we have equation number 2 that we can now use to graph our points. Let's see, what do we have as far as our equations? I'm going to write them here so that way we'll have them on this paper. Y equals -3x minus 3. This is equation 1. And y equals -2/3 x plus 5/3. That's equation 2. Okay. So now let's take this and, come on. Let's take this and graph both of these equations. When we're graphing in the y equals format, the first thing we do is identify the y-intercept. The y-intercept here is -3. So we go to -3, we graph that. Our slope is -3. There's an invisible 1 under here. So we go down 3, we have to rise, or we go down 3 because it's negative. And we go over 1, and this is our second point on the graph. Down 3 and over 1. That's 2 points. We're ready to draw a line for those two. Okay. This was our equation number 1. And then we have equation number 2. Let's use a different color. See if we can find something else that works for us. To graph here, we have a positive 5 over 3, which is 1.666, right? So our y-intercept, 1 and some change, so 1 in the middle here. Can we see that? Oh, yeah, we do. Okay. 1.6, and we're going to also have a negative slope here. We go down 2, 1, 2, and over 3 to the right, 3, 2, 3, and our next point goes here. Now that we have those 2 points, we're ready to draw our line. This is equation number 2. Okay. If we look, we can see where there very well may be a connection point here. Looks like the two graphs cross here, and they cross at -2, 3. Looks like this is the point -2, 3, and it crosses there. Okay, looks like this is the place of meeting, and that's the solution. The way we find out for sure is to go back into these first two, these equations, substitute negative 2, 3, and see what we come up with. Let's see. Does y equals negative 3x minus 3? Well, y is 3. Does that equal negative 3 times negative 2 minus 3? Well, 3, does that equal 3 times 2 is 6 minus 3? 3 does equal 3. So yes, this is the solution for the first equation. We can check this one off. Looking at the next one is, does 3 equal negative 2/3 times negative 2 plus 5 over 3? Well, does 3 equal negative 2/3 times 2 is positive 4/3 plus 5/3? Does this equal 3? Well, 4 and 5 is 9 over 3, and I believe 9 over 3 is 3. So yes, this one is also met. So that negative 2, 3 is the solution to that system of equations, which we've identified by way of graphing. Okay? Now, there's other ways we can solve systems of equations. We can solve them by adding and subtracting. We can solve them by adding and subtracting. Let's get us some nice clean paper here. So if we have an example, let's do example number 3. System of equation x plus 3y equals negative 3 and negative x plus y equals 5. You take these two equations, if you add them together, we're adding these two equations. You add them. X plus negative x is basically 0. Plus 3y plus y is 4y. And this equals negative 3 plus 5 equals 2. Solving this for y, we divide both by 4. This simplifies, and we have y equals 1/2. Then we take and substitute this 1/2 back into one of these equations. It doesn't really matter which one you substitute into. I try to go with the easier of the two. I'm going to put labels next to these. I try to go with the easiest equation to substitute back into because there's a little less math and less opportunity for you to make a mistake. So I'm going to substitute into equation 2. Equation 2 is negative x plus y equals 5. We're substituting the 1/2 in place of the y. Negative x plus 1/2 equals 5. Well, in order to get this set, we have to subtract 1/2 from both sides. Negative x equals, if we subtracted 1/2, we'd have 4.5. Divide both by negative 1 because we want positive x, not negative x. So x equals negative 4.5. Our solution here, according to these two, is negative 4.5, comma 0.5. I turned it into, or negative 4.5, comma 1/2. You can turn it into decimals or into fractions. Either way, you probably should be consistent between what they are. If you want to make sure that you've done this correctly, you can substitute this solution back into both of these equations and make sure that it works. Okay? Another example. Example 4. We have 2x minus 7y equals 2 and 3x plus y equals negative 20. In solving this example, you're looking at what can we do to one of these equations to make this be easy to add them. We're going to add them, but we need to have equal and opposites in order for this to work. So it probably would be good for us to multiply this second equation by 7. Why multiply by 7? Well, this is already negative 7. If we multiply this by 7, then we'll have positive 7y. So let's do that. We'll keep the first equation. Let's go ahead and multiply it first. So 3x times 7 is 21x plus 7y equals negative 140. Then I'm bringing equation 1 down. I'm just going to put it down here because it makes it easier to add them when they're right next to each other. You can really see what's going on. We're adding these two. So 21x plus 2x is 23x. The plus 7y minus 7y cancels out, and you're left with negative 138. If you divide both of these by 23, divide by 23, see what does that equal? 23 goes into 138. Where's my, cannot find what I'm looking for. Where did it go? Where did it go? $138 divided by 23 is 6 times. Should have been able to do that one in my head. So x equals negative 6. Well, now you have x equals negative 6. Now we need to substitute this back into one of the equations. It's up to you which one you pick. It's really not relevant. I'm going to substitute into the 2x minus 7y equals 2. Either one would work. So we've got 2 times negative 6 minus 7y equals 2. So negative 12 minus 7y equals 2. You add 12 to both sides when you're solving. These reduce and simplify. Negative 7y equals 14. Divide both sides by negative 7. And you're left with y equals negative 2. The solution for this system of equations is negative 6 and negative 2. If you're not sure if that's the solution, which I think you always should do this, you should go back and substitute this solution back into these two equations, the two original equations, not the ones that you had to change, to find out if this solution is true. All right? So we've solved systems of equations by graphing, and we've solved by adding and or subtracting. We really did 2 addition examples. Subtraction works the exact same way. If they're the same sign, you can subtract them, and you clarify that. In our next video, we will continue with systems of equations, and we will go on with how to solve by substitution and elimination. Our next one will be how to solve systems of equations by substitution and by elimination. We have for you the Algebra Survival Kit. The Algebra Survival Kit is a full comprehensive resource that includes everything you need to pass your college algebra class. It includes fractions, it includes decimals, it includes integers, it includes exponents, it includes, it includes everything. What else does it include? It includes equations, it includes inequalities, it includes videos and worksheets and quizzes and solutions, all the things that you need to be able to pass your algebra class, you can get in this survival kit. And for this month, the survival kit is available for $50. Usually it is $88, which it'll go back to $88 on March the 1st. bit.ly/algebra, bit.ly/algebra-survival-kit. Mixing up my dashes and slashes. You can go there and see all the stuff that's included in the algebra kit, knowing that it is a fully comprehensive tool that will ensure that you pass your algebra class. All right? So we look forward to seeing you in the next video. If this video has been helpful to you, then subscribe to the channel so you can be notified when new videos are posted. Also, visit us at 8minutemaths.com where you can see our content and resources and courses, things that are available to you there. Lastly, follow us on Facebook at 8minutemathshelp.com. We look forward to seeing you there.